In this video clip, we will go to the first order logic, okay, and we will use the resolution. But before we can use the resolution, we have to know something first. In first order logic, the difference, or you may think that the extra things that difference from the propositional logic is the first order logic can use the variable, and because you can use the variable, so you have to do something. The variable can be any, can be combined. Actually, the technical terms of the word to combine variable with the constant is to unify or unification. You can change the variable to any constant, but in the same sentence you can change it just only one time. Once you change it, you cannot, once you combine it, you cannot combine it, you cannot change it to any other variable in the same program, in the same rules. Okay, so in first order logic, the idea is almost same as the propositional, but it's a little bit more complicated because you have to deal with the variable. And the other thing is you have to deal with the quantifier for all and for some. It's a little bit complicated. Okay, so I'd like to start with the conjunctive normal form. So you have to change, you have to convert the sentence into conjunctive normal form first. Okay, we start with the rules, with some rules that is like this. Same as the one that you already learned from the previous video clips. For example, if you have a pit here, okay, you must think about the pit can cause debris, right? So for all x, if x is a pit and adjacent x and y, then I'm sorry that I would like to rewrite this. Okay. Then it must be breezy y, right? So for all x and y, this is the cause of breezy, right? But if you have some case, like if you have something that is breezy, if you have some cell or some grid that is breezy x for all x, then there must be some grid y that is adjacent x and y and pit y, right? Because if you have a pit here, if you have a pit here, it must be, if you have a breezy here, breezy grid here, so it must be at least one cell that is a pit. So if x is breezy, there must be a cell that is adjacent to x that is a pit. So the rules in the real world is look like this, but sometimes some rules is more difficult. Like a dog, the one that we started in the clips before this, uh, a dog, there is a dog that can run faster than all rabbits, something like that. Or there is a person who like a dog that can run faster than a rabbit. Yeah, a little bit complicated, right? Right. There's someone who like the dogs that can run faster than all rabbit in the world, something like that. But that's like very complicated. But the one that we always use is like the level of the level complex structure is like almost like this. So to convert these sentences into conjunctive normal form is at first the first step, convert sorry convert to conjunctive normal form is the first step is to eliminate if, then, and if and only if. For if, then, you have to change it to not and or, right? And for if and only if, you have to change it to if, then, and if then, right? I hope that you can still remember. If we have P or Q, you have to change it to not P or Q. If you have P, even only if Q, you must change it to P then Q and Q then P, right? Okay, this is the first step that you have to eliminate all if then and even only if. For the second one, okay, I'll show you an example. So for all x, y, x is a pit and adjacent x, y, then breezy y. You have to change it to for all x, y, not pit x and adjacent x and y or breezy y. Okay, and the second one is move not inward. So from the previous sentence, we will move this not into this sentence. So it will be not pit x or not adjacent x, y or breezy y. Okay, so then for this example, you just do like you can drop universal quantifier. So it will be not pit x or not adjacent x and y or breezy y. And that's all. Easy, right? But sometimes you have to, if there's for some, the existential, how can you do it? I have some examples after this. Okay, so uh, we will look at this example. Okay, I would like to copy. I would like to copy this one and duplicate. How about this one? Sorry. Okay. Uh, at first, you have to eliminate if the if then, right? So for all x not breezy x, or for some y adjacent x y and pit y. For the next step, uh, actually you have to move the negation inward, right? There's no parenthesis here, so we can skip. So after this, we have to drop the universal quantifier, but in this case, we have the existential quantifier here, so we cannot drop it now, because for the quantifier like this, for the existential, you must do something like we have to change this into we will use the scholemization process. What is the scholemization? This scholemization is mechanisms, is a process that you can change for some into another variable to make it be able to be removed later. So if uh, for some is in the scope of for all, you have to change the variable here into another function. We call it the scholemized function. Guys, let's consider just only this part: adjacent x, y, and pit y. What does it mean? It means that there must be an adjacent of x that is a pit, right? That is a pit. So one thing that you can do is you can create a function we call the scholemized function, that it gets x as a variable and return, actually it return y, that is y that is adjacent to x. Okay, so it can be like this: adjacent x and ax and pit ax. Okay, so now we can eliminate y already, right? So before you can eliminate, you can remove for all, you have to change for some to be scholemized function first. Okay, or we call it the scholem function. So from this step, the original sentence will be breezy x, or now y will be changed to adjacent x and ax, and pit ax. Okay, so the the next step is, at this point you have to, here you have to distribute for sorry, or operation over an operation here. Also, after you use the Golem function, you can drop to for all quantifier also. So in the third step, you must distribute or over and. So it will be not breezy x or adjacent x and ax and not breezy x or pit ax. I'm sorry that I forgot this. Adjacent, the predicate must be started by the capital letter. Okay. So finally, you will get two sentences here. This one and this one. Okay. You can find, if you can find some x that is adjacent to breezy, that is a pit. Okay. Not breezy and or x adjacent x. So this one is true, right? Okay. So now we can conclude the step like this. To convert to CNF, the first step is replace or eliminate if then and if and only if. Okay. By not and or. The second step is you have to move not or negation inwards, and then eliminate for some and for all. You can drop for all, but for some you have to use the Scholemite function. In some case, you can eliminate using some variable, like for example, if for all, if for some is not in the scope of for all, you can change that variable into some other variable. If the sentence is like this, you can change x into some Scholen constant like R1. That is the billionaire one, something like that. Because this is same, right? Same meaning, that you can find some x, and this one you can replace x by this variable. This one is called Scholen constant. In the case that for some is not in the scope of for all. Okay. For number 4, after you eliminate for some and for all, You can eliminate for some and for all. And the last one is you have to distribute, and over or. Okay, it's quite easy, right?